Empezamos. Well, okay, so I will do it in English. Okay? So what I will present is the second part of the seminar that I gave last year, but many of you weren't present at that time. So in that seminar I explained some basic things about Python, and I focus in how to use it to create scripts and to run programs with, for example, swipe parameter regime using this script. So one of the questions was if Python can also be used to make a graphical interface for your program. So you can put your data there, your parameters, and then run the program from there. So this was an open question, and then I decided, because some people wanted to learn how to do it, I decided to give a second part of the seminar explaining how to do this kind of things. So, the outline of the talk is mostly this. Well, first I will explain what is Python and why it is useful. Then I will explain what is WX Python and Boa Constructor, which are the programs that we will use to create the graphical interfaces. And then I will give one example, which will be the main part of the talk, on how to do a graphical interface for a program. And well, I will upload this talk, and well, you can find the seminar recorded on the webpage of IFISC. So the talk has only a few slides, and most of the things I will tell them with the computer. I will do the program live, and so the recording will be the most useful thing. So what is Python? Python is I already told this last time. It's an open source programming language which is available for a very broad spectrum of platforms like Windows, Linux, Mac, etc. It's a strongly typed language. This means that every variable in the OS has a type. It needs to have a type. If something is an integer, it is an integer. It cannot be a string. Or if something is, real double precision, it's a real double precision. It cannot be an integer. It's dynamically and implicitly typed. This means that dynamically means that you don't have to define all the variables at the beginning of your program. You can define them wherever you need them. And it's implicitly typed. This means that the variables will take the type of the first definition. If you define a equal 1, a is an integer. If you define a equal 1.0, a is a floating point number. Okay. Then, well, Python is case sensitive, so this bar and this bar with lowercase and big bar are two different variables. This is important because sometimes people used to, I don't know, for me, that I'm used to programming in Fortran, sometimes I make mistakes with these kind of things. It's object-oriented, which is, this means that everything is an object, and this, well, for people used to, again, to Fortran or to C, this is the most confusing part of programming in Python or programming in C++, which is an object-oriented language, because the philosophy behind the programming is quite different. And object-oriented programming becomes really important if you want to program things with windows and sliders and stuff where you can input text, and all these kind of graphical things are managed by objects. And so the objects become really important. We will see in the examples how understanding how these objects work is really useful for this kind of thing. And well, this Python has a very clear syntax. It's really nice to read, and well, sort of, you will see. But it's once you are used to read it, it's very logical and nice to read, and it's very easy to use. It's quite fast to to learn. The learning curve is quite fast. I mean, I started using it because I needed to do a program with a graphical interface for some biologists, and I learned to do it in 2 weeks, from nothing until I managed to do all sorts of things with Windows and plots and all the stuff. So and there is a lot of information in internet. You can start, of course, going to the Python webpage, and then they have a lot of tutorials. And for example, here you have a tutorial in Learn Python in 10 minutes. So in 10 minutes you can learn all the basic things of Python, well, at least how to define stuff and to define functions and all that kind of things. Why do you need to learn Python? Well, you don't need to, but if you do it, well, you can work a lot faster and do a lot of things easier, like as I said, or as I told in the last seminar, you can do, for example, simulations in batch. You can run a lot of simulations, changing parameters in a very easy way, or if you, for example, you need to run simulations and then you need to run some other ones depending on the result of the previous one. You can automatize all this work by scripting and do all kind of fancy stuff. And this is what I explained the last time. You can create scripts to run your programs and interact and plot results and whatever you want, analyze the data and act in consequence. The thing that I will explain in this seminar, which is to create graphical interfaces, and we will see that it's quite easy to do. And well, of course, it's always good to learn new things, and it's one of the easiest way to learn object-oriented programming. So if you learn Python and you learn object-oriented programming through Python, then you can jump to more complicated languages as C++, for example, and then you don't have the psychological drawback of learning object-oriented programming and a new language altogether, a hard language as C is. And well, to run Python, you just type Python in any terminal and it's fine. So what I will explain now is WX Python. WX Python is a module of Python. A module is like a library that you are used to. It's like a module of Python that enables you to create and manage Windows and graphical components. And this library, the good thing, the nice thing of this library is it's available for Windows, Linux, and Mac. So if you program something in Python using this library, you can run the same script in any computer using Windows, Linux, or Mac, and you will see the same results. You will obtain the same program. It will work all the same. So this is really good if you have to interact with people that is using a different platform from you, and you want to give them the possibility to use your programs. And I will use Boa constructor. You see that the programmers are as funny as physicists with the acronyms and the names of the stuff. So it's Python, and the constructor is named Boa. And it's a graphical interface that allows you to create these windows and save a lot of coding. Because we will see that it enables you to draw the windows that you want, put all the components, and it will automatically create the code that create these windows in the program. So so I will now go to the example, but I want to point out that there are three main ways of interacting between Python and your code. So you have your code in Python, and you have some program that you have in, for example, in Fortran, that you program like 10 years ago, and you don't want to program it again. So you want to use the same libraries and all that, you know that it's working and it's producing nice results, but you want to use it in maybe with a more convenient interface. So there are three ways to do it. The first one is to just have this program which runs by reading some parameters from a file. So what the Python program will do is create this parameter file and then run the program using these parameters. And then you can wait it to finish or whatever you want. Then another thing which is fancier and is in some well, in some scenarios it's better and maybe it's more, how to say, it's more elegant, is to convert your code to a subroutine of C or Fortran or C++, and then integrate this subroutine into Python. So Python, what you can do with Python is to call some subroutine in Fortran, which is written in Fortran, call it from Python. So your code will be a subroutine, you compile it all together, and everything together, and then you have one Python code which runs everything. And all the code is included in the same file or in the same program. So these two things, you can do it in a local computer. And another thing that this is the one that I will explain today because it's the easiest one, and I don't want to go into the details of this because we won't have time. But the other thing that you can do is also run some pre-existing program in the same way that you do it in your local computer, but in a remote computer. For example, using SSH, you can do a Python script that connects, for example, to Nureduna from your local computer, sends the parameter file, sends the code, or the code is already in Dolsa, and then runs the code and waits it to finish or whatever, or close the connection and leaves the program there running. So in some sense, this way that I will explain is the easiest one, and probably is it's not the more convenient in the way that our cluster is built here, because the thing is, if you run your if you want to use your local computer as Nureduna, so if you want to run code in Nureduna in the way I will explain now, you have to run your Python code in Nureduna, which will create a graphical interface and export it with the X Windows system to your local computer. So if you do it for one small program, there will be no problem. But if everyone starts doing it and do it for lots of programs, the connection with Nureduna will be quite crowded, and Pera will kill us, or at least me. So if you do this, do it carefully. And if you see that the connection with Nureduna has become slow because everyone is doing this, I really don't think that everyone will start doing this. But if it happens, just we try to do it in a different way. I mean, this thing is this way is the best way, because you run the code, the Python code, in your local computer, and then you run the programs in Nureduna as we do it now. But we do it now by hand. You have your code you have your editor, for example, Kate, in your local computer. You compile the code in Nureduna and run it there through an SSH window. So this is the best way, but it's more complicated, and I won't go into the details on how to do it. But if someone wants to do it at some point, you can ask me, and we can see how to do it. And this is also a nice way, but in this way you also running in a local computer, so you can also do this in Nureduna. But then this is, well, it's more elegant, it's a more elegant solution, but then you have to keep your program, your graphical interface open while your subroutine is running, and well, it has some other complications. The good thing of this is that, for example, if you have a subroutine integrated into the Python code, you can see the data on real time. So if you have a matrix that you want to plot, you can give the matrix back to Python, plot it, and then keep running the code. For example, you are integrating some equation. So you can integrate the equation for 10 time steps, go back to Python, let Python plot the results, and then run for all 10 time steps or whatever. So you can do one these Java applets that Juanito has used to. So, well, I will go now to the second and more important part, which is the programming. So, I will switch now to this program Boa, which it looks really awful here because of the resolution. But so what we have to do first is to, of course, create a new program. So the Boa constructor is basically has three windows. This one, which is the IDE selector. Here you have all the components of your program. So for example, here I have this is the main application. I have a window, dialog boxes, containers, whatever, sliders, text control to put text or write things. Alright, so I will create, the first thing I will do is to create a new application. Okay, so this is WX application, I created. So it creates some code. Okay, it will create two files. The first one, this one is the code of the application itself, and this code creates is the code for the main window. Okay, so I will save it now. I hope. Okay, I will put it somewhere. Now I don't know where I save it. Okay, it's in Windows, whatever. Okay, so I save it, and then if I run it, I will close this. If I run it, I have just a frame. Okay, it's empty. It's an empty application. Okay, so now we will start putting some things into this. So what I will do first. So you see that this is a code, but I didn't write anything. So Bora is taking care of writing all the hard part of the code, which is the one that controls everything. So I open here. This is the editor. Sorry, this is, well, I should put this in English, but you see all the drawings. Okay. So this is the editor. Here I have my frame, which is now empty. Okay. And the first thing I will do is to put a panel, okay, inside. The panel is something which is just in the back of the window and contains all the other elements, because the frame, as the name says, is only the frame of the window. It's not the window itself. So I will click on this and I put the frame. I click on the panel and I put it on the window. Okay. So I like it, and so I say okay here in the inspector. I close it. And it writes all the code again, and it writes the panel. You see here that here I have panel 1, which is the panel that wrote this before. So I save it again. I won't run it again, so this will go faster. So I close it. When I open it again, the panel now occupies the whole frame. If you use only one panel, the panel will always occupy the whole frame. So you don't have to worry about the size. It will have the same size as your window. And here you can resize the window or whatever, and the window, this size will translate to the code, and you have the size in your code. Okay. So what I want to do now is to put here something where I can put the parameters for my file. Okay, what I want to do is to put some parameters and then a button. Then when I click on start, will run my code. Okay, so the first one I will put, I don't know, this a slider. Okay, and I will call this slider. These are tags only to put static text. I will put it here. Okay, so I have my slider and I have my text. Now the text that displays is static text. So this is not very nice and very useful. So I will put parameter A. Okay. So I go back. So this is parameter A. And then I want to input something which I can put. I don't want the slider. I want to have more control on what I put. So I will put some text. Box where I can input some text. Okay, so I will move this here. This will, Bora will assign the names of all these things by itself. You can change it, but I will leave them in this way, so I don't have to start making up fancy names. And the value of this text control at the beginning, I will put it to, for example, to 0.0. Okay. So this will be 0, and I will put it also the name. This will be, of course, parameter B. So I press to the OK, so it closed, and here it added all this stuff that I added before. Okay, so if I save it and I run my code again. Run. And now I have this, which so far doesn't do anything because I didn't tell you to do it. And then I said, okay, I say that I want, I go back to the editor, I said that I want, this is maybe it's smaller, and then I said that I want a button, so I will choose the button here, and I will put it here right in the middle, and I will call so here this start. Okay. I go back, and this is start. Okay, so what I've done so far is to create the window, and as you see, well, what I told you about the object-oriented programming is that everything that you see here is an object. So the frame is an object, the panel is an object, and all these tags and the slider and the text box, everything is an object. Okay. So this means that these objects have their own properties, and I can create them and destroy them. Okay, so this is the nice thing about objects. So objects, I won't go too much into the details of object-oriented programming, but the thing is that the objects belong to a class. So this WX Windows module has defined some classes. There is a class for the frame, there is a class for the panel, there is a class for the text tags, there is a class for the slider, whatever. So every time that I create one, I'm creating an instance, what is called an instance of the class. Okay? And this instance of the class has all the properties that the class itself. Okay? So if the button is defined that it has some size and it has some, I don't know, so some color or whatever, every instance that I define of the button will have all the same properties. But then on each instance I can change these properties. Okay? So I mean I can access all the properties of each instance and change the properties. So for example, one property of the button is the label. Okay, so generically there is some property of the button which is label. So I assign the value start to this label, to this property. Okay, so this is why it's important. If some of you try to program, for example, in Visual Fortran, which is not object-oriented, you see that doing this without object is really painful. It's because it becomes a mess. You start having a lot of functions, a lot of things, and it's really, really difficult to operate with this kind of thing. And with the object-oriented, it's much easier. And if we see now, if we go back to the code, you see that maybe it's hard to see now, but it has some. If you see, it has some logic and some structure. Okay, you have this is the frame which has everything inside. Okay, so I'm defining this. Well, it's a technical detail, but this is defining a new class of the frame, which is just a copy of the old one, but modified with all this kind of stuff inside. So this is the panel. This is the slider that I draw. This is some of the text, and you see here that this is the name, and well, this is the text of parameter A. This is the text of parameter B. This is the text control where I can input the data, and so on. Okay, this is the button, and this is the other static text. Okay, so I go back to my frame, and what I want to do now is to the program to interact with me. Okay, so if I tell you to do something, do it. Okay, if I press the start button, I need the program to do something. Okay, so how to do this? So I select the button, and then the holy grail of window programming in window, not by Windows, but all these kind of things is events. Okay, is how your components reply to the action of the user. So what I want to do is to tell this button that I want to add an event. Okay, so I go here to the event pestaña, or this tab. Okay, yeah, and I want to add an event that when I click over this, do something. Okay, so this is really easy. It has some predefined event, but the main event is event button, which is when someone press over the button. Okay, so I will double click here, and it will what this will do is to bind this event to this function. Okay, so every time I press on this button, it will call this function, and then the thing is that inside this function I can put whatever I want. Okay, so I can do whatever I want. So this is, well, on bottom one button, this is the name of the function. I will leave it like this. I will do okay. So you see that we have all this code that it created, but then at the end it defines some function, which is this function on button one button, then that I can edit. I cannot edit this. Yeah, it puts a flag that this is a generated method and don't edit. So I cannot edit what is in this method, but I can edit what is from this function down. Okay. So now I will start editing, and what I will do is to put everything I want that to. So when I press the button, the program runs my code. Okay. So the first thing I have to do is to import. Well, I will erase this. This tells the program that if the function is empty, to skip it, to do nothing. Okay. So this is what it's doing now. So if I press the button now, it won't do anything. Okay. So I erase this. And what I will do is, well, first import this model OS, which allows me to interact with the operating system of the computer. So I can send commands to the operating system, and this is the way in which I will send the command to run my program. Okay. So then what I need is I have this slider and this text which have some parameter that I put there, but I need to retrieve the values. Okay, so I will retrieve the values. So this is done in this way. This is called self, because self means that all these things belong to the frame. Okay, so every time I need to call something which belongs to the frame, I will call it in self. Okay, because I'm inside that. So the name of the slider is slider 1. Okay, so this means that the slider 1 belonging to this means that, sorry, I will put it so you can see it better. This means that I'm calling the slider 1 belonging to the frame, okay, which is called self now. And then what I will do is call with the dot, I call a function that belongs to this object. Okay, so the slider is an object, and I will call a function that belongs to this object. And this function is get value. Okay, so of course all these kind of functions, you have to look them on the documentation of WX Windows, but most of them have these very obvious names like get value. So get value will return the value of the slider. Okay, and you call it in this way again because this is self.slider is an object, and this is a function that belongs to this object. Okay, so it will copy the value of the slider into A. Okay, then I do the same with the text. So it will be self. Let me see, the name is text. I will copy from here so I don't make a mistake. Okay, and this is get value again. Okay, you see all these methods are the same for both. So now I have the values of A and B, and what I will do is to create a file where I will put these parameters, so that then I can pass them to my program. So I will do I don't know, f equal to open some name param in this is the mode in which I'm opening, which is write. I want to write inside the file. Okay, so now f is an object which is a file. Okay, and I have all the methods that I can do, all the functions that I can apply to a file. Okay, so now I have the file and I can do some writing. Okay, so if f is equal to f, I call the function write inside the file, and I write well, this is just this is some formatting code. So I do 4 floating number spaces of the parameter A, because the thing is that this slider gives me back some value A, which is a floating point. So if I want to write it, I have to tell the Python how many decimal points I want to write. But then we will see that B is not, inside this I can put anything. Okay, so this is a string, so I don't have to convert it and I can put it. The thing is that I have to be careful, because if here my Fortran program, for example, is expecting a double precision number and I put patata inside here, it will say patata and the program won't run. Okay, so you have to be careful, or you can put some functions to control what you are putting. Of course, you can put in the program, you can put an if. This is not if A is not of class double, stop, or put some indication. Okay, so I will put this A, sorry, this goes like this, and I put some an enter. Okay, I will put some space. Okay, so I return the line, and then I write the second one, which is B. So I write B, which I don't have to write anything, because B already is a string. Okay, and then well, I can write also an end of line. Okay, there is no need. Okay, so then I close my file. Okay, and that's it. Mainly that's it. Okay, so now the program, what it will do is to in the line in which when I press the button, it will write this parameter file, and so far won't do anything else. Okay, so what I want to do now is to run my program. So I can do now I need to use this OS, which is this model which allows me to interact with the operative system. So I call the model, and you see that the model is also an object, and it's called in the same way. So all the functions that exist inside this model are called by calling the name of the model, a dot, and the name of the function. Okay. So again, I do OS system, which sends a command to the system, and then here I write the code. So I write to run program. So my executable is named program.x. And I send the param.in to the input, okay, of the program. Yes?
I'm using 2 parentheses after the code.
Sorry. Yeah. Okay. So I run this in the system. So I run to the system this program. So this will run the program. Well, I can put here an ampersand so it runs in the background. So I can close my. Yes.
Will that work also in Windows? Because that's bash what
well, if you do it in Windows, you probably will have to run your. Now, if I run it like this, it won't work because I don't even have a program that text that. But no, if you do it in Windows, what you can do is to, for example, read from a file with a predefined name, which can be defined in your code. Already?
I don't use Windows, just I wanted to point that that's your...
No, if you do it in Windows, in this way it won't work. But most of the people here use Linux, so yeah. But if you do it in Windows in this way, it won't work. Yeah. Because it doesn't accept parameters put in this way.
If you will put the absolute path to the program, I think it will work. Well, maybe you will have to...
No, but I think that Windows doesn't allow to pass parameters in this way.
But well, it depends on the program .x. How do you pass parameters? You can pass them just as arguments, not as input.
Yes. If you pass them as arguments and you don't write the parameter file, you can do it also in Windows. But what I mean is that in Bash, this means something which Windows doesn't understand. Okay. But yes, you can do it. You can change the.
The thing is that OS system is
OS system is universal.
Yeah, exactly. It's universal. You can use it
You can use it both in Windows or in Linux. Yes.
So you just have another syntax for Windows.
Yeah, for Windows, what you need to change is what you write inside here. But for example, I want to run in Windows something which is, of course, it will be program.exe. Okay, and that's it. I mean, I run it like this, and program will read the parameter from this file in which I already specify the name. Or I can do, for example, program.exe and the param.in, okay, and I tell program.exe to read the parameter file from the string that I put in the command file, okay, and I can run the same. I mean, I can do it. I'm just explaining for Linux because what most of the people uses, but there are ways on doing it in both platforms. So I will change this again. Well, I won't run it now, but in case, so it's complete. And so, so far, okay, so this is most of it. And now the thing is, for example, I want to do, what can happen now is that maybe I forgot that I already ran the program, and I will go and try to run it again. Okay, so I will first comment this so I can run it and doesn't give me any problem. But what I want to do now is to tell the program that if there is something which is already running, so if I press the button already, don't do anything, okay, or give me a warning at least, okay. So what I will do is I will define here this def init is what the program does when it starts. Okay, so everything that I want to initialize when the program starts, I have to do it here in def init. This is a function which is run when the frame is created. Okay, so what I want to do is define some self.started, okay, which is equal to, in this case, we put it equal 1. Okay, so this means that the program hasn't started. Okay, so it should be 0, but okay, and then I will put here if self started, and then so this what this will do is if started is equal to 1, it will run this if, and if it's equal to 0, it will jump to the else. Okay, and then as this is Python, one very important thing is that Python understands what is inside the if because of the indentation. Okay, so I need to indentate all this inside. It can be done more than a way, but I will do it like this, so we have no problems. Okay, so everything that is inside this level is inside the if. Okay, so if it started, I will do this, and if not, I will do different. What I will do is to draw a dialog which tells me that the program has already started. So this is I will show you this is the only part of the code that of Windows that I will do by hand. Okay, so I will write here. This is an object that I will create, and this object is a message dialog which is already defined in WX Windows. So this is okay, message dialog, which belongs again to self, so it belongs to the frame. Okay, it has some message which is okay, they will tell me that there is a program already running. Okay, sorry if I open like this, I close like this, and then this is of kind error. This is the title of this small dialog, and this is the type. So it will only show me one button which says OK. Okay, this is the only thing that I can press, and this I can put some icon. This is just fancy stuff. Okay, this will show me some icon of information. Okay, so I tell the program now to show this dialog. Okay, and then So this show model, sorry, it's not model, it's model. What it will do is show it, but don't freeze the program. If I only tell show, it will show it and it will freeze the program. I will not be able to do anything until I click OK. But in this case, I can go back to the other window or whatever. And it's better to use it in this way because if not, you can sometimes produce situations in which the user doesn't know what to do. The dialogue is lost behind some frames and it cannot press it and it's a mess. So it's better to do it in this way. And then when I press the OK, I just destroy it. Okay. So this line creates this object, which is dialogue. Then I show it, and then I destroy it. And this only will show the information that I want. Okay. So now, if I didn't write anything wrong, it should work. Okay. So at least it's working. And then I press start. Doesn't do anything, and then if I press start again, doesn't do anything because probably I wrote something wrong, and it will show me an error here.
The starting has to change to 0.
Sorry, yes. This is a problem. So self-started, yeah, has to change to 0, okay. So start doesn't do anything. If I put anything, it tells me that it's already running. Yeah.
You call it a show model and then it shows up. And why is it waiting for you to press OK? No. I'm very shy. Why does it? Why you can put the destroy straight after the show model, and it waits till you press OK? Why is that? Like I don't.
Because this show model leaves the dialogue. The next instruction of dialogue will run after you press OK. But all the other things in the program will keep running in the back. Okay. For example, you have a program that is computing something, and you want to show a dialogue telling the user that I don't know there are whatever 10 times state remaining to finish or whatever. But you want the program to be computing in the back. If you only put show, it will show the dialogue, but it will freeze all the rest of the program until you press OK. And the show model keeps the program running in the back.
And when you press OK, it goes to the code right after show.
After show model, yes. So, well, this is most of it. Okay. So there are some other things that, for example, if you want to, I don't know what time is it. Well, maybe it's already time, but you can put, for example, in here some other, because you have the slider here, but you don't know which the value of the slider is. So, for example, I want to put something which tells me the value. Okay, so I will put some text here. Okay, this will be static text string. Okay, and then I will assign to the slider an event. Okay, which tells me that if I scroll the slider, it will go to a function. Okay, so this is the event scroll here. Okay, so I need a function that is called when every time I scroll the slider. Okay, so I do this, I do everything okay. So I have all this stuff here, and I have this new function which is a slider scroll. Okay, and then what I will do is to assign to this slider self static is okay. This is done like set label. Okay, I will change the label to the value of the slider. Okay, so I have to convert it to string, and I need to put self. Well, again this. Okay, self slider 1 get value. Okay, and then I close. Okay, so this, what it will do is to assign to the label of this text that I wrote, it will assign the value of the slider. Okay, so I will copy this, and I will tell the program that every time I scroll the slider, it will update the value of the text. Okay, so if I run it again,
Two cells.
twice,
And the other.
and the other one. Okay, so I will run it again, and now I have at 0, and if I run it, it will change the number. Okay, and you see this is predefined between 0 and 100, but you can redefine this in whatever way you want. You can scale. Okay, so well, mostly that's it. If you have any questions or comments, yeah.
Okay, it's independent of the platform, but you need.
What you need to install is BOA and WX Windows. So we can ask Ruben to install the.
But if you want to use your RAM in another computer, this computer has to use the Python and BOA.
Well, if you have no, if your program is written all in Python, so you don't have any code written, for example, in C or whatever, which needs, because if you have, for example, if I want to do what I told, that is to use a subroutine of Fortran inside my Python, this subroutine has to be compiled for every processor and for every operating system. Okay, but if I write all my code in Python, I can distribute this code. There is a way to distribute it without without the user to have to install Python in the computer. There is a Py2exe application which is also written in Python, and you do Py2exe this program, and we compact everything, put the Python inside, create an executable file, and then you can send this, and they can run it wherever they want. The only problem is if you have some code which is not in Python, and you have to, this needs to be precompiled. But this is a problem with every, well, except if you use Java, which is, then you wait all your life to finish the program. You cannot do anything serious in Java. So.
How do you do a plot? Yeah.
So, well, to do plot is not so complicated, but not so easy as to show it now. But this, for example, this panel, this object called panel has some, this one, okay, has some functions which are basically draw. So I say self panel draw x, y color, and it will draw a point there. Or you can there are some primitives already defined, which are circles or squares or whatever, and you can do it in this way. So drawing this kind of thing is quite easy. It's just like that. You put only this function. It's a bit more complicated if you want to draw something which have axes, which you are not drawing it by hand, because if not, you have to write every line and draw all the ticks and the letters and everything, and you have to write a lot of code. But there is also derivation of this panel, which is I think it's called plot panel, which allows you to draw x's and all this kind of stuff. So it can be done with some modifications to this, but following the same philosophy.
There is a specific module to draw.
Well, there is also PyLab, for example, that you can use, which is it's a whole module to do plotting and all the stuff. But if you want to plot just one plot, is easy and is relatively good to do. But if you want to do is to update the plots while your simulation is running, this is pretty slow. So it's not the most convenient option. But this PyLab, for example, is, on the other hand, it's very complete. It's practically MATLAB for Python. So everything you can do in MATLAB, all the kind of plots, 3D and all the stuff, you can do it also in Python, and you can integrate it quite easily in your code. So, for example, you can run the code and wait it to finish, and then plot something in 3D or whatever. For example, this PyLab also has a PostScript output. So your code can run the program and generate the PostScript output altogether. So all these kind of things can be done, and all the philosophy is more or less the same. You have your model, this model has some objects, and you call the function of these objects.
How fast is Python?
Well, not that fast to do scientific computing with it. So if you want to do something like, I don't know, inverting a matrix, you won't do it all in Python because it's slow. But there are a lot of precompiled things. For example, there is NumPy, which is all written in C++ and comes precompiled. So if you tell NumPy to invert the matrix, it will call a function in C and it will invert it really fast because C, but with the advantage that the interface is Python, so it's easier to write. And then to do these kind of things like small windows and all the stuff, it goes it's really fast. There is no problem with today computers. There is no problem.
Yes. And it's integration and everything. I just found out. But I have 3 comments. First of all, one comment to you don't need to have the BOA installed on the other machine.
No, BOA no. Yeah. 2 things. One is he said that the WX would not be fast enough to update plots while calculating. No, WX it will be, but not Python.
Yeah. Another question. Maybe this is too. If this is too far, we can do that after. But like you have one frame now in your application, and now imagine that you want on runtime do the same frame twice in the application, because one is for application A and the other one for B. So you basically would just call another instance of frame 1.
Yes.
But does it work?
I think if you do it, well, you don't have to do it here because this is a definition of the class. Okay, but if you do it in the app, then here you do again main2 equal frame 1 create. It will create 2 frames.
Within the same.
It will. Well, the frames are 2 different windows. Frames
panels.
But if you do, if you can do for example, inside here, if I want to I can put the division here and put 2 panels, and this will work. And I use one panel to have the sliders and whatever, and the other panel to write the output.
No, basically the idea is to have one object which has 2 sliders, 2 whatever, 3 buttons, whatever, and have a copy of that. And then they'll just change a parameter, like you have like one.
Yes. You can do it, but in this case, not in the same way in which I'm doing it now, because what you need to modify is the class of the panel and not the class of the frame. Okay? Because now what I'm modifying is the class of the frame. Okay, so all the sliders and all these things belongs to the frame and not to the panel. But if I do a panel, I don't know, Nico panel, and I put all these things inside the panel, then whatever I call it will put all these things inside.
Okay, but what you said, if you do 2 of them, your application would have just 2 frames, but it would be the same. Like the concept would be what I was asking.
Yes. Mm-hmm. Okay. Yeah. No more questions?
Do you have other examples here?
No, I don't have. No, but we can discuss some things in particular if you want. But I have a really complicated one, which is this program that I made for the biolosis, but it's like, I don't know, it's like several thousand lines. It's really huge. But yes, because the thing is, this is really easy because I'm explaining something which is, you will use it and you know which are the limits and the boundaries of what you can do and what you cannot do. But if you are going to give a program to someone which can do basically anything with it, you have to put a lot of code to control that these people don't break the program. Or so, for example, this silly thing that maybe I need here only floating or strings or whatever, and I have to check that in every parameter that I put, I have to put the right kind of variable, and I can put whatever I like. So this is every time you check on one of these things is another line. And if you want, for example, if I want to put, I want to check this, and if this is not what I want to raise an exception. So I want to put a dialog telling this is not a floating number. So all this you have to write it, and then it becomes increasingly complicated.
I'm curious, in this program when you have several thousand lines, most of the lines you've written by yourself, or?
No, most of the lines are written by, I would say half and half.
Okay, that's good.
Yeah, half and half. But yeah, these kind of things save you a lot of work, because basically you don't have to worry because the other important point is that if you want to write this by code only, without this help, you will find out that it's quite complicated, because I have to say, okay, I want a window, which size? Okay, put something, 300 by 400, okay. Is large enough, is small enough, I have to run it to check. Okay, put parameter A tag, put it where? Okay, put it, I don't know, 30% down, 10% to the left of the border. Okay, then I put the other one, and I have to put in the most basic way of programming, I have to put everything by hand. So I have to check everything is in place, and this is a lot of work, in this case I don't have to worry about that, because I move it, I put it where I want, I see the frame in the way it's going to be when it's finished, and that's it. Then there are some more advanced techniques of doing this kind of things, which are called sizers, in which basically what you do is to define a matrix, and you put the things inside the matrix. So in this matrix you can stretch it. So if you have this window, because the problem is here, if I have this window, but then I run this in a computer which has only this resolution, I won't see anything, okay? Because I will only see this part of the frame, okay? But these sizes, what we'll do is, okay, I will define the frame not in absolute value, but in a ratio of the total size of the screen, and it will shrink the window, trying to accommodate, of course, within certain limits, trying to accommodate it to what I want to show. But this is more complicated. There is no point to show it now. Okay. There are no more questions. Can stop recording. Okay.